type of system is a rainfall activated displacement system. So how it works is we have a catch tray. So say this is a square metre. So inside this little reservoir here, there's multiple holes. So as the rain collects on the catch tray, it fills up in here. Now you can choose when you think it's going to start to generate runoff, and you adjust the hole to suit. So at this stage here, it's about halfway up. We're going to capture about 10 mil of rain before it fills up and goes in to start displacing any coagulant. So you can set it on a sandy soil. You might go, well, we might bring that all the way up to the top. We know it's going to have a fair bit of rain before it's going to have to inject any coagulant. So we want to work out what the catch tray sizing needs to be. So take say this is a 1 hectare catchment that was leading to our basin. 1 mil of rain on that 10,000 square metre with a runoff, total volumetric runoff coefficient of 1 will give us 10,000 litres. Of runoff entering here. That 10,000 litres of runoff, we go back to our dose rate at 0.03, means that we're going to have to dose 300 mil. So we need to displace 300 mil of our coagulant to treat that 10,000 litres of runoff from 1 mil of rainfall. So we do that by going, okay, we've got the coagulant has a specific gravity of 1.37, so we need 1.37 litres to be in rainwater to displace 1 litre of that coagulant. So you do your calculations to that. You then set your catch tray. Sometimes it works out that it's just a full tray and it's all happy days. Otherwise you get a half tray like this. You might go, well, I only need, instead of you might only need like half a square metre exposed. So that's 500 mil of rainfall that'll go in there instead of a litre. So if it's 1 square metre, 1 mil equals 1 litre of potential displacement. We close that off to a half. We're only going to get half a litre of displacement per 1 mil of rainfall. Half a litre of displacement will push out about 300 mil. Yeah, somewhere. Yep. I've actually lost it in my head there.
So the Auckland guidelines, I did mention this in the talk, that they have basically a design procedure. It's exactly the same thing as what this is. It's just basically built out of ply and different tanks. They also talk you through those calculations. Once you do it once or twice or 3 times, they become pretty simple. But I know there's a lot of converting and creating what's the rainfall into how much do I need to displace. But there is a step-by-step guide to do it. It's likely if you're doing it on your own or you're building your own, you'll be doing that. Otherwise it may be something, if someone's supplying one of these systems, it's likely that you're going to say, this is the product I want to use, this is our catchment area, and they'll probably work out what size the catchment tray needs to be for you.
So if you think, alright, so in here you've got your coagulant reservoir, and it's full to the brimming point here. This sits on top. The rain collects in there, goes out one of the little holes, fills this thing up. As it rains, this thing gets heavier and displaces the coagulant out this line. Is one, you've got a reservoir. For this example, it's 200 litres, but you don't actually get 200 litres of displacement. You get a fair bit that gets caught around the side. So you can work off 150 litres potential. At that point there, you need to get the maintenance team to come through, empty this of water, retop the coagulant reservoir, and reset the system.
It's simple enough to do. Won't need to be done every event, but if you have a big event, it's likely you're going to have to get in there, tip the rainfall out, and put more chemical bases.